This video here is about the present value of an annuity. There is a previous video about the future value of an annuity, and I will pop that link up here at the top so you can go watch that video if you haven't seen it first. But I've taken that formula from that page to show you how to find the present value required for some amount in the future. So let's say you want to save for retirement and you have a set number you want to reach, or you want to save money for a down payment, for example, for a house. There's the formula here that you should use. So we're going to come down and work this example, and it's going to work very similarly to that previous example. So we have some amount of deposit we don't know, that's the P. We have 5% interest rate, that'll be the rate. Compounded monthly means it'll be 12. Our time is 13 years. And our financial goal is $190,000, and that will be our A. So let me put all that into the formula, and then we'll calculate it. So I've substituted my values into that formula. So let's be very careful here with the calculators. We calculate this. So we'll put in 190,000, put our first parentheses, and 0.055 divided by 12, close that parentheses. Then we're going to divide, and we'll start two parentheses here. Notice we have two in the way we've written it out. So parentheses, parentheses, 1 plus 0.055 divided by 12, close parentheses. We're going to raise that, and again, we've spoken of this before, but there's an implied parentheses. When that 13 and 12 are multiplied up in the exponent, you need to add a parentheses for that. Then we'll minus 1, and we'll close our parentheses. And our payment, our periodic deposit, is going to be $836.65. And we need to round up to the nearest dollar. So we're going to take $836.65, we'll round up to $837. And then for part B, it says blank of the $190,000 comes from deposits, and the other blank comes from interest. So our deposits will be $837 per month for 13 years. So we'll take 837 times 12 times 13, and that'll give us the first answer choice. So the sum of those payments is $130,572, and so then the amount that comes from interest will be the difference in the total sum of $190,000. We'll take away the $130,572, and we'll get the final amount for the interest, and that number is $59,428. So I'm going to also demonstrate the Microsoft Excel functions here to do this as well. This one's a little bit trickier than in the last video, but it will do it without all this complicated formula. It will do it for you. So let me pull up Excel. And so as I suggested in the last video, if you come up here to the formula bar and you click on the function here, it will bring up a list of all the functions in Microsoft Excel, and there's a whole group of financial ones if you select by category. The one we're looking for here is going to be called PMT for payment. It wants to tell you what the payment is you need. So the tricky part about this one, I'll explain. So just as in the last video, if you're compounding at a regular interval, you take your interest rate and you divide it by the number of times compounded. And your number of periods is 13 times 12 because it's that 156 payments. It's 12 payments a year for 13 years. Now the present value, we don't know what that is. So we're going to leave that blank, or you can put a 0. But we know our future value, our FV, is going to be $190,000. And so you see we get our same number here. We get $836.66, which rounds up to $837. And again, we also spoke about how that is showing as a negative number. In this case, that actually works out to be a negative number because that's money we're going to have to take out of our account. We're going to pay that money out, so it's a subtraction from our money right now, and we'll build to $190,000 of positive money in the future. So I hope this helps, and again, go back and reference the previous video. I'll put a link to that here in the end screen.